Hey everyone! Get ready to unlock a super powerful JavaScript feature, generators. Ever wished a function could just hit pause and then pick up right where it left off? Well, that's exactly what generators do. They're not your typical functions, they return an iterator, making them perfect for handling sequences of data, asynchronous operations, or even creating infinite data streams efficiently. This is a game changer for control flow. At its core, a generator function, denoted by an asterisk function, doesn't execute its body immediately when called. Instead, it returns a special object called a generator object, which conforms to the iterator protocol. When you call the .next method on this generator object, the function executes up to the first yield expression, pauses, and returns an object value, done, false. The value is whatever was yielded. Crucially, its local state is preserved. Subsequent calls to .next will resume execution from exactly where it paused, continuing until the next yield or until the function finishes, at which point done becomes true. You can use this. You'll often find generators incredibly useful when dealing with potentially infinite sequences, like a stream of unique IDs or Fibonacci numbers, without consuming excessive memory. They're also fantastic for simplifying asynchronous code flows, especially with libraries like Redux Saga, by making complex sequences of operations easier to read and manage. Another great use is creating custom iterators for complex data structures. Now let's break down the code line by line. First, we define a generator function named idGenerator using the function syntax. The asterisk signals to JavaScript that this is a special function that can be paused and resumed, allowing for incremental execution. Then, inside the generator, we initialize a local variable ID to 1. This variable's state is crucial because it will be preserved across all pauses and resumptions of the generator, maintaining continuity. Then, we start an infinite while true loop. This setup, combined with the yield keyword, allows the generator to produce an endless sequence of IDs without blocking the main thread or consuming excessive memory upfront. Then, here, the yield keyword is used to pause the generator's execution and return the current ID's value. After yielding, the post-increment operator ID++ increases ID by 1, preparing it for the next time the generator resumes. Then, we call our generator function idGenerator. Crucially, this call doesn't execute the function's body immediately. Instead, it returns a generator object, gen, which is an iterator ready to produce values when its next method is invoked. Then, we call the .next method on our gen object. This resumes the generator, causes it to execute up to the first yield, and returns an object value, 1, done, false. We then access and log its value property, which is 1. Then, calling .next again resumes the generator from its last pause. It executes up to the next yield, which is the same yield ID++ in this infinite loop, returns the increment ID, 2, and logs its value property, which is 2. Finally, the console output clearly shows the sequence of IDs produced by the generator on each call to .next. This demonstrates its ability to maintain state across invocations and generate values on demand, making it ideal for sequential data. Generators are a truly elegant solution for managing complex sequences and asynchronous patterns. They bring incredible flexibility to your JavaScript code. Now, I want to hear from you. Comment below which JavaScript concept you'd like me to demystify next. And if this video helped you understand generators, hit that like button.